Hello? Is there any wrong with my answer for part A? Ramisa, can you read my answer for part A? Question 15, 2014. What is my answer? Hello, are you in Times? No, I just want to make sure everyone is in that question. If not, what for I discuss? Ramisa? Hello, can you hear me?
Yeah, we can.
Yeah. So Wengson, what do you think my answer for 15 part A? Is my answer correct? Okay, before you decide whether my answer is correct or not, let's talk about the skewness of the distribution. Okay, we know that the highest part will be the mode. Correct? So every distribution, you know where is the mode exactly. Yeah. Okay, if it's normally distributed, that means the mean is also here. The median is also here. Okay, so the mode, the mean, the median will be the same. So that is called normally distributed. So if I ask you, my mean is this one. So this is my x. So if I ask you, what is the probability that x greater than the mean? So who can give me the answer for the middle one, the normal distribution?
50%.
50%, yes. 50%. Hello, I'm saying this question first. Please go to this question first. 50%. Because this is also the median. Median means what? What is the meaning of median? If my median is, okay, for this case, my median is K. Okay, so I will say 50% of X is less than K. Right? So the other 50% will be more than K. That is the meaning of median. So the mean, the median. So for normal distribution, this area is 0.5. This area is also 0.5. Okay. If the distribution is skewed left, so the lower value, you have extreme low. So the mean is pulled down. So here will be the mean. Here will be the median. Okay. So that means this area will be 50%. So in my median here is K. So my mean is mu. So therefore, probability of X less than mu will be less than what? Will be less than what? Ethan, can I have the answer?
Less than K.
Yes, less than what?
Less than K.
Less than K? Cannot. K is the value of X. I'm talking about the probability.
Oh, sorry, miss. 0.5.
Yeah, thank you. Less than 0.5. So that is the meaning of the skewed left. Okay? The median is bigger than the mean. So the probability of X less than the mean will be less than 0.5. Because we know that 50% of the value will be less than K. Are you okay? So for skewed right, the right value, there are a lot of very big positive value, okay, to the right. So that pull the mean up. So the mean is here. So the median will be here. Okay, so this shaded area to the left of the mean is also 0.5 to the median. Okay, so that means probability for this case, probability of X less than the mean will be greater than 0.5 or less than 0.5. Rachel. Rachel, can you tell me this one? What should I put down? Which symbol?
More than
This one?
0.5.
Yeah, more than 0.5. So now, can you based on that, based on the distribution of the question 15 part A, you think which is the correct statement? Which is the correct statement? Mikia, can I have the answer? There are 3 choices there. Can you tell me which is the correct one? The distribution for 15A is skewed right.
Yes.
Yeah, Mikia, can I have 15A answer? I have no choice. I have to call your name to make sure everyone is in the class. Mikia, 2014, question 15.
Yeah,
The
fine.
mean for this case from the one is 0.89. $0.89. So that means the median will be less than 0.89, right?
Correct.
Hello? Mikia,
Yes.
which is the correct statement? On the basis of the information above, which one of the following statement is true? Can you read the first one?
Question. Okay. Oh, got it. Less than half of all smartphone apps cost 0.89 more.
So less than. So you choose the true one is the first one is wrong, correct? So less than half of the smartphone app costs 0.89 or more, because this is skewed right. This is 0.89. Median is here. This area is 0.5. So more than here is less than 0.5. Less than half of all smartphone app cost 0.89 or more. So that is the answer for part A. Are you okay? Okay. So answer for part B, the histogram. Yeah. Write down the mean and the standard deviation of this distribution. You are talking about X bar 50. Right? Okay. Can I ask Clarissa, what is the mean for this distribution? Clarissa? Clarissa? Clarissa. Am I pronounce your name wrongly? Or you are not in my class? Clarissa? Okay, Jared?
Yes, miss.
Yeah, what is the mean? For,
$0.89.
yeah. So is the equal to the population mean, correct?
Yeah.
So this one, every one of us know. So how about the standard deviation for this one?
You asking me, miss?
Yeah, yeah.
2.42 divided by square root 50.
Yes, divided by square root of 50. Clarissa, you better respond. So that's why that is how I get 0.34, correct? Okay. Then they say using the normal distribution determine that one. So that one is fair enough. You use normal CDF, correct? So that one, everyone will know what to do. Yeah, normal CDF, then you get the answer. So you have the answer to check. Okay, now, how many of y'all got difficulty in C part 1? Okay, to do C part 1, okay, I'm going to forward a picture to you that I draw it nicely so that to explain to you why that is the situation. Okay, can you please go to your WhatsApp? I'm going to forward a picture that I draw it nicely to show it to you why is it like that. Can you see? If you assume it is normally distributed, but this histogram is skewed right. So because every time when I try to explain to you, when I draw on the screen here, correct, it's not very accurate. So I spend some time to draw it accurately to let you have a look at it. Sienna, any question on that? Can you understand? So if the probability predicted is greater than, and if it's skewed right, then it will be underestimate. But if the count probability of less than, then it will be overestimate. Hello? So if skew left, that means the other way around. Are you okay? Marcus? Understand? So this part, better take note. For the past 2 years, it doesn't come out on that. Hello? Marcus, are you okay?
We explain that again.
What did I explain again? Okay, which one? What did I explain again?
About it skewing to the right. And
Okay, do you see the area I shade? Okay. You want me to explain skew right, or you want me to explain this part C?
Part C.
Okay, part C, you
again.
look at the picture that I give you,
Mm-hmm.
and I draw a normal distribution, correct?
Yeah.
So you see the area that I shade with pencil, 1.8 and above, the area big or not compared to the histogram?
It is small.
Small. So that means the chances of it to be more than 1.8 by assuming it is normal distribution is less than the actual situation. So that's why you use normal distribution to get the value that is underestimate. The actual one is more than 0.00392.
So normal distribution is
Symmetrical, ma, I even count the standard deviation, you see or not? That means 3 standard deviation away is almost 100% already. Am I right?
yeah.
Yeah. So to be more than 1.8, the chances is only 0.00392. But the actual histograms show more than that. The probability is more than that.
Oh, okay.
That is how we analyze. There are more mean that is more than 1.8.
All right, I think I got it. Yeah.
Yeah, for example, if I have 1,000, if I have 1,000 mean, okay, I collect the data of 1,000 samples of 50, and each one I count the mean. So according to normal distribution, I hardly get anyone that is more than 1.8. Correct? Because if I use 0.000392, I time by 1,000, I only get 0.39. I can't even get one of them. This is my number of sample. That is how you look at probability. But if you look at the histogram, they are. That's why we say this is an underestimate probability.
Chair,
Hmm?
are the rectangles like the rectangles we draw for over and underestimate? So then we shade a normal distribution curve, and because 0.00392 looks like the underestimate rectangle, then it's underestimate
Yeah.
because it's smaller than the actual rectangle that it drew.
Yeah. That is how we judge. So you go by the rule. If it's skewed right, so you just bear in mind, if the distribution is skewed right, and they give you the probability of greater than by using normal distribution, then the probability that you counted will be underestimated. And if they say less than, that means that will be overestimate. So that is the one that I bear in mind. Because in the exam, you can't afford to draw. So you have to get prepared.
So skew
yeah.
right means that when they say that it is
No, you look at the distribution. You look at the distribution. You look at the distribution in question 15, correct? Yeah. If you look at the middle, yeah, you look at the middle. You see 0, after 2, they are still got, but after 0, no more. You see or not? That is the meaning of skew right. The right value is much, much bigger. The difference, the deviation from the mean to the right is more. To the left is. You get me? So if I use a block, this is my mean. This is my lowest possible. This is my highest possible. If you look at it, it's 2.3. So isn't it, this is longer, this is shorter, this is 0.89. So that's why we call this skewed right. If skewed left, that means it will be this the other way. Here is the mean. Here is the lowest. And here is the highest. So this one we call it skewed left. So the histogram will go like that. This kind of thing. So this is called skewed left.
We can say like some.
The
So when they ask whether it
distance
says
of the
when
lowest
they ask
from the mean is longer.
when they ask whether it's overestimate or underestimate, right? We compare the skewed left, skewed right to a normal
Yeah.
distribution and see if it's bigger or
compare
smaller.
to what they ask. Like for example, in this case, I ask probability of X less than, for this case, a value, less than any value, 5 or whatsoever, I don't know, less than 0.32. Okay? For this one, it will be overestimate.
I see. Okay, you know what makes sense, Steve.
So it does depend on the skewness and also the sign and in the probability. But for this case, if I say probability of X, okay, my mean is maybe 3, and I put a 2 here. Okay, so X less than 2. Okay, you see this is less than and it's skewed left. So this will be my underestimate. I assume normal. This is the assumption you assume normal.
I see. Okay. I understand.
You cannot afford to say, I want to understand exactly how is it. Now, what you need to do is you record down. If it's skewed right, they ask for probability of X greater than, whether it's an overestimate or underestimate. Because it's skewed right, greater than will be underestimate. That is how I record down mine. Because during the exam, you have no time to slowly think. Do you know how long I take to draw this one nicely for you? At least 15 minutes. Are you okay? So
Yep, I wrote it down in my
mark,
notes.
just for the 1 mark, you spend 15 minutes is not worth. So that's why all this you have to get ready and put in your notes. You just need to write 2 sentences enough. Then the other one, you will know what to do already. The opposite, you just do the opposite, that's it. Hello? Rush, are you okay?
I'm slowly processing.
Yeah, because all these 1 mark, 2 marks is very important for your A. It's extremely important. By the way, please don't get me wrong for those. Yeah. I'm not saying I look down upon you, please. You write down properly, you still can score this 1 mark. You cannot, 1 mark, you can only take 1.5 minutes to process. That is how we engage, how long I should process. So, do you think you can process this by start from scratch using 1.5 minutes only? Can't. That's why we give you notes. You don't think that everything, I understand, then in the exam, you try to, based on your understanding and try to process it, then you take, that's why you cannot finish the paper. Okay, that's why they say give a reason, because this graph is skewed right. So you talk about the skewness of the distribution. You see, they say, when you go to, can I move to part D? Okay, when you go to part D, correct, we find the probability. You say probability of the sample mean less than 0. There is a chance. But if you look at the histogram, is there any? No, that's why this is overestimate already. That's why hence comment on the use of normal distribution to model the distribution of X bar. So it's just an estimation. Because the distribution of the X bar 50 is not normally distributed, it's still right. Are you okay? Can I? Okay, have I tried my best to explain the whole thing to you?
Cher,
Mm.
can we just generalize, say if it's skewed right, so there'll be more values on the left-hand side. So if you do less than, since there are more
More
values,
value on the right hand side.
oh my God, okay. I think I messed up my
Right-hand side.
understanding.
Yeah.
Okay, check. Then can you explain D one more time?
Huh?
Can you explain D one more time?
Okay, D is because you look at the histogram. The lowest is 0, correct? But when we
Yeah.
do a normal distribution, there are value less than 0, am I right?
Yeah.
So that's why probability of X bar 50 less than 0, there is a probability. Can you give me the probability? 0.004. Am I right? 0.004654. Yep. But if you look at the histogram, 0 is the last one, correct? After 0, no more, am I right? So according to the histogram, probability of X bar 50 less than 0 is 0. So look, this is more than 0. So that's why this is an overestimate.
Okay, I think I'm slowly starting to get it now. Yeah. Thank you.
I know some of you, if you cannot get it the way how it relate, you cannot memorize. Right? Even you write the statement, it just simply copy. So you are not satisfied. I know. One of my grandnephew also like that. I also explain until he can get it. Okay, look, this is you assume it is normally distributed. Correct? So you use normal CDF to get this answer. Right? But if you, according to the histogram given, is there any number that is less than 0? You look at the histogram. No, correct? So if I go according to the histogram, probability of X bar 50 less than 0 will be 0. Am I right? So that's why we call this value as overestimate of this. Can I not? So you know why I say the general rule is like that. If it's skewed right, they ask for probability less than will be overestimate. They ask for probability more than a certain value, it will be underestimate. Okay? And in between, very difficult to judge. That's why part B, they didn't ask you to judge. Can or not? Okay, anyone have difficulty in sketching the normal distribution graph? Please go and learn it up. And please try 2019 paper. There's one they ask you to sketch the other graph. They give you the population. They ask you to sketch the sample mean. Okay. So any issue on this question? No, okay. So just now someone asked me to explain 2019, is it the tri-exam paper or the final paper? Can I know? Is it the tri-exam paper or the final paper?
It's the final paper, Miss.
Final paper 2019.
Yes,
Where's my
Miss.
2019? Yeah. Okay, everyone go to 2019 final paper, question 15. Final question 15. Okay, someone want to explain C and D? Okay. So I start from the beginning first. It's easier to explain in that way. So the question is, you see, as what I said yesterday, right? I say they give you y equal to x ln x minus x. So they want you to show that dy dx is equal to, so dy dx, this one you use product rule, this one you use basic rule. So product rule, ln x times 1 plus x times derivative of ln x is 1 over x, take away 1. So you got ln x plus 1 minus 1. So you got ln x, done. 2 marks. So, and we know that, okay, so you see, this is the question. So they say, an overestimate of the area between the graph of y equal to Okay, so that one calculate the overestimate, underestimate, no problem. Okay, then we go to the next one. C. So they say that consider the definition of n factorial. N factorial means n times n minus 1. So explain why ln n factorial is that. Okay. So I'm going to explain part C. So look, ln n factorial. The question says n factorial means n times n minus 1 times n minus 2. Yeah. Then times until the last one is 2 and 1. Okay. So this will be ln n plus times become plus ln n minus 1 plus ln n minus 2 plus until the last one is ln 3, ln 2, and ln 1. Okay. Yep. So ln 1 is 0. Right? So how are we go there? So that's all. So it will be start from here, ln 2, that's it. That is how you get your 1 mark. Okay, I answered the question already. Okay, then D. Part 1. They say find the expression for the overestimate of the area between the graph of y equal to fx and x axis from x equal to 1 to x equal to n using n rectangles of equal width. So the width will be, what is the width? What is the width? Hello? How to get the width? N minus 1 divided by n. Right? Because n rectangles of equal width. Okay, so the overestimate will be equal to the width. Okay, look, the graph go in this way. Yeah. So this is 1. Here will be 2. Then it go on. Right? 3. Then the last one will be, you use n, am I right? So it will be ln 2 plus ln 3 plus until the last one ln n. Am I right? Because this function is y equal to ln x. So I will have n minus 1 over n, and this one, according to this one, is ln n factorial. You see? Have I explained? Hello?
Yes,
Is my answer
miss.
correct? Is my answer correct? I don't know. I just do. Long time I didn't do it. Yeah. Okay. Question 12. How come my question, where is my question 15 answer? Okay. Right. How come my answer is ln n factorial?
Yeah, it's different.
Correct or not? It said from 1 to n. So the width should be n minus 1 divided by n. Okay.
Yes, miss.
Hello. So my answer is the width is 1. Actually, the width is 1 unit. No, it's not 1 unit. 1 to n. N rectangles of equal width. Yeah. Should be n minus 1 divided by n. Yeah, so the answer is wrong. Okay, so it's the width part that is wrong. Okay?
Yes, miss.
So any other thing? I'm overconfident. The width should be the highest minus the lowest divided by the number rectangle. So it's better for you to put it that way. Okay. Any other question? Same go with the other class. It depends on what question they want to ask me. So now is the more you ask, the more I explain, the better you are. Okay, any more? Or you are still working on other subject? Yeah? Junjie, is there any question, Junjie?
No. I guess lah.
You guess you got do your work or not? Junjie, just tell Miss Dola, it doesn't matter.
I do the common one. I will start the past year.
Oh, you haven't started the past year. You better start to do some of it.
Okay, sure.
Okay. So how about the rest? Kelvin?
Yeah, I did, but still practicing more on the SAT paper as well.
Your SAT paper, if those you know how to do already, correct, class, you don't have to go through in detail one. Only once you look at it, correct, you hesitate, then you then you try to solve it. If one look, you know the answer already, correct, you don't have to, you just take the answer and okay, good. Like that only you can make your revision faster. You are not redoing one by one. Those one look, you know the answer already, just let go. Can or not?
Yes, Miss.
Then you can go fast. Like if you are doing this way, correct? Maybe for your SAT practice, correct? Each day you can finish one SAT one. Because you just go through, okay, this one I know already. Okay. When I look at certain question, I'm not very sure. Then I look in detail, then practice again and see where you are not sure of. Then decide whether you need to ask me again or not to explain the concept so that you know better. Okay? Not redoing. Only certain question you need to redo. You can't afford to do all over again. That is how you revise for your final. Only those, when you look at it, you still have to think twice how to do it. Then you really try that question. Okay? If not, I'm not going to hold you. Okay, so get prepared. Yeah, after this week over, you only have 2 weeks to go. And your maths is your first paper. Don't wait until last minute. Please